I want to take a look at another electric field example. This one's a little bit different than what you saw yesterday. So this one says determine the magnitude and the direction of the electric field midway. What does midway mean? Halfway in between this charge and this charge that are 20 centimeters apart. When you get a question like this, an electric field question that has more than one charge in it, please draw a picture. Please draw a picture. Here's the first charge. It's positive 100 microcoulombs, or 100 times 10 to the minus 6 coulombs. And then we have a second charge over here that is negative 75 microcoulombs, or 75 times 10 to the minus 6 coulombs. We have a distance that separates them of 20.0 centimeters, or 0.200 meters. We want to find the field strength right here, right smack in the middle, midway, 0.1 meters from both of these charges. Now, what I want you to do here is treat this as if it's two separate questions, at least for now. Let's cover up the second charge. Doesn't exist. At least for now, it doesn't exist. We want to find, first of all, the direction of the field caused by charge number 1. Which way is it? Which way does it point? Left or right? To the right. Points to the right. How do you know it points to the right? The field points away from positive toward the negative. It points away from the positive because that's the way that a positive would move if placed in the field. And we're positive the field is with the force. So we're going to call that E1, field number 1. Then we're going to pretend that object number 1 doesn't exist. Which way does the field point caused by this negative particle? Oh, I heard to the right and to the left. Which way is it? It's to the right. The field points away from the positive, that would be the red one. The field points toward the negative, that would be the purple one. Now I've got to calculate both of those fields. We're going to say E1 is KQ1 over R squared, which is 8.99 times 10 to the 9, times 100 times 10 to the minus 6, divided by what distance? Amanda, what distance am I going to use? What's the distance from here to here? 0.100 meters. Let's figure this out now. 8.99 times 10 to the 9 times 100 times 10 to the minus 6 divided by 0.1 squared gives me 8.99 times 10 to the 7. And then we find the other one. Charge of the negative is 75 times 10 to the minus 6, divided by the same distance. What is it? Oh, negative 6. So I think that's going to be 6.7425 times 10 to the 7, isn't it? Now, what do we do with those two numbers? It's easy now. Easy. Add them up. You can see maybe now the value of not including the negative sign with this charge. Listen, I'm going to write down something in yellow. Do not copy what's in yellow. If I make this negative 75, because it's a negative charge, I'm going to get a negative right here, right? And then what's my temptation when I go to combine them? Add them up, but add them up as a negative value, right? And that's not what I want to do. I want to make them both positive because they're both in the same direction. Remember I said before, you don't want to include the negative sign of the charge, because for us, in an equation, negative means direction, not type of charge. There you're kind of mixing two sign conventions together, and that doesn't work for us. So add these up. And when we do, what do we get? $6.74 times 10 to the 19? No, it isn't. Oh, yeah, yeah. $1.57 times 10 to the 8. Right? Please, 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 when you get one of these questions, and you're going to get two of them in a moment, draw the picture. Show the fields. Think about which way they point. And then once you get the values, just combine them as positives and or negatives. For the next little while, I'm going to get you to work on questions 8 and 9 from that worksheet on the back side of that worksheet. 8 and 9. All right, question number 8. I want to get the picture drawn for question number 8. We have a positive charge here that's to the left of another one that's a negative charge, and we want to find the field strength midway between. Field strength right here. What I want you to do when you're trying to find the direction of the fields is choose one object at a time, one charge at a time. So let's look at the positive, pretend the negative's not there. Actually, let's make the positive another color. Let's make it green. We're going to find the field strength right here, all right, smack in the middle here. The field caused by the positive is going to be to the right. We're going to call that E1 to the right. Why? Because it's away from the positive. Fields always point away from a positive charge, and fields always point toward a negative charge. So we're going to say E1 is to the right, but so is E2, away from the positive toward the negative. I calculate both of those values, I add them up, and I get my net electric field. Now, question number 9, we've got 3 charges in a row. The first charge is 2.5 times 10 to the minus 2. It's positive. The second charge is negative 4.0 times 10 to the minus 2. And the third charge is positive 3.00 times 10 to the negative 2. We want to find the field strength to the right of the third charge. We want to find the field strength over here. Now, the field caused by the green one is which way? Forget about the blue one and black one for a second. The field caused by the blue one is, or sorry, the green one is, to the right. It's away from the positive. Forget about the blue and the black. The field caused by number 1 is away from the positive. The one caused by number 2, the blue one, is to the left. It's toward the negative. Fields always point towards the negative producer. And the third one, the black one, it's positive. So the field here points to the right again. That's away from the producer. Now, calculate all 3 of those values, add them up, make sure that E2 is negative, and you should get your answer here. Be careful of a couple things. The fact that we have millimeters here and centimeters here. You want to be consistent units. Specifically, you want to be in meters with those distances, right? So 60 millimeters is 0.06 meters, and 2 centimeters is 0.02 meters.